Okay, so this is the second video for Unit 6. And this is going to be kind of a brief intro or summary of the Atkinson-Shiffrin model for human memory. Sometimes you'll hear it called the three-box model because there's three boxes or three layers to human memory according to this model. And it's going to go from the environment, or like out here where all the information is, what we're going to try to remember, or what we are going to remember, things that we hear and see and smell and taste, etc. And then deeper into the mind, into eventually the long-term memory. Okay, so remember we talked about last video and what we've been talking about in class. Going in, information going in is encoding, and then we retain information, it's storage, and then when we need it, we bring that information back out, and that's called retrieval. So you can kind of see the process. So as we're looking at the screen here, we got sensory memory. We're going a little bit more deep into the short-term memory, the working memory. So we see something that's really important or something that has an emotional tie that's going to exist in the long-term memory or be encoded further into the long-term memory, where when we need it, we can pull it back into the short-term memory for use, right? Whether it be someone's name or what's that smell or whatever it is, right? That long-term information resides in the deepest part of the memory model here in the long-term memory. So I'm going to click through here. Again, this is super important. If you blow this up or you look at it here in the video, this will get you to pass the AP exam in terms of the information for this unit. This is the stuff that's always going to be on it. And if you just study and create this flow chart and kind of even draw it out yourself, which will help you encode, this is pretty much what you need for memory. You'll see this a few times in the notes. Let's start here with the sensory memory. So box one, we're starting here with sensory input. Environmental stimulus, light, sound, chemical, pressure, temperature, all that stuff that we have the tools to pick up, and transduction happens, and all of a sudden we have neural energy or brain power, right? Something that our mind understands. Remember, there's two important senses when we're talking about sensory memory, ones that have been studied more extensively. Iconic memory, which is visual sensory memory, and echoic memory, which is auditory sensory memory. Just think iconic, icon or I, and echoic, echo, like echo, something you can hear, right? It's kind of an easy little mnemonic way to remember that. So your sensory memory contains or can process a lot of information. Think of all the photons and all the chemicals you smell and taste and all the different sounds you hear. It's a lot of information that's being processed at any given moment. But the vast majority, 99.9%, is pretty much immediately forgotten. So if you want to look around your room and you look away from something, you're not going to retain a whole lot of what you were just looking at, right? But there are things that you find important you're going to pay attention to. They're going to get encoded a little more deeply. We'll talk about that in a second. So the amount of information that sensory memory can hold, and in particular the iconic and echoic memories can hold, is a lot. It's lots of pieces of information. How long does it last? Not very long. And we'll see this in class, and we'll do little demonstrations for iconic and echoic memory. The iconic memory, if I flash letters up on a screen and take them away, how long is that information going to last? How long are you going to be able to pull back that information and say, yep, this is what I saw? And you'll see this with George Sperling's test of iconic memory. And if you want to try that, feel free to go ahead and try that and test yourself. What we're going to see is iconic memory, it lasts less than a second. As soon as you look away from something, most of what you were just looking at is gone. And the reason is our brains or our minds kind of evolved to know that we don't really need all that information, because what can we do? If you think you see something, you look away, all you have to do is look back, right? And that stimuli will still be there. You can still see it, assuming it hasn't run away or hasn't gone pitch dark or whatever. But you can look back and recheck and see if it's something you need to pay attention to. Echoic memory for sound is a little bit different. And it's kind of cool. I think of this kind of like a little superpower, because echoic memory lasts a little bit longer. And you probably have noticed this. If you've ever had a parent, you're ignoring them, you're texting on your phone, or you're in class or whatever, and parent or teacher goes, "What did I just say?" And you could have been completely ignoring that person. And you could reach back into your mind and you can grab that echo even if there was no attention being paid to that stimulus. You can grab that echo and pull it back in and go, you just said da 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 da. And, obviously they'll be mad because you called them out, or they were trying to catch you and they couldn't catch you. You can thank your echoic memory for that superpower. So echoic memory still holds a lot of information, a little extra special because it actually holds on to that stimulus for a couple seconds, even without attention. If you think about the nature of the stimulus, the sound wave, it's not like sight where you can just look back. Once the sound wave passes you, it's gone. You can't run and catch up. So I think that's why the mind has evolved to kind of maintain that sense, that sensation, even after it's gone. Okay, so important out here, and you'll see me drawing on this during class too, and this is what it's in these notes multiple times. You want to know what the sensory memory is? It's the first layer of memory. It's sensation, it's transduction. You want to know what iconic memory is? Visual memory. Echoic memory is auditory memory. Okay, moving on here to short-term memory. So short-term memory, or now what we call working memory, it's what you're thinking of right now. So again, use something from this course. We talked about consciousness. We know what that is. It's an awareness of yourself and your surroundings. So how are you aware of your surroundings? You pay attention to something, right? It makes you aware of it. You could even use those things synonymously. So how do we encode things into the short-term memory? We pay attention. A crucial thing here for when we talk about working memory or short-term memory is that it's got a very limited capacity. And we'll do this in class as well. Need to know this guy, a cognitive psychologist named George Miller, which we'll see on the next slide, did a test of the capacity of working memory. And he found that the magic number, the number of things that we can kind of retain at one time, is 7 plus or minus 2. So 7 unique pieces of information plus or minus 2. Or you could say 5 to 9, right? Same. And he did this using a digit span. So basically, it's a fancy way to say a line of numbers. How many can you remember? Again, we'll do this in class, and you can do it on your own here if you want to use these slides. But to get things into working memory, same thing. If you want to remember the digit span, you got to pay attention, right? If you want to keep things in there, you can continue thinking about them. That's called rehearsal. Also, to get things into short-term memory, they can come from the long-term memory, right? So kind of the short-term memory, the working memory is what your executive function, what you're thinking about right now. Stuff you're looking at from the environment, and also not even just looking, but things that you're sensing from the environment, and then also bringing long-term memories in from deeper in the mind. Okay, so here you go. You've got your working memory. Short duration, you can keep things in there with maintenance rehearsal. The magic number is 7 plus or minus 2, and this is your conscious mind. Okay, things to add into your mind map, and again, we'll talk about these things in class, and you have the textbook pages linked up here as well. Working memory, another name for short-term memory. Selective attention, it's how we encode things into the working memory. George Miller studied the capacity of the working memory by using digit span, and he found the magic number is 7 plus or minus 2. We can maintain things in the short-term memory using what's called maintenance rehearsal. So it's just thinking about them over and over. So if we do the digit span and the number is 232, 233, you're going to say those things over and over in your conscious mind, in your working memory, to keep them in there, to maintain them. We'll talk about memory interference in class later, and you'll see PORN as our acronym, which is kind of funny and weird, but it's a good way to remember it, and this comes up on the exam all the time. And then serial position effects, which is another thing we'll talk about in class. And I'll even bring these number 5 and 6 up in the last video for this unit. All right, lastly, the long-term memory. Most of you have heard of long-term memory. It's your pretty much unlimited capacity for maintaining and storing information. It can be everything from procedural type memories like how to ride a bike or how to tie a shoe, how to type, to episodic memories like what did you do on your last birthday, things that have happened to you, to semantic memories, long-term memories, which is just facts, like what's 8 plus 8, right? Or who was the first president of the United States? Lots and lots and lots of different kinds of long-term memory that have just kind of been stored in there. It's what makes you, you, right? So a couple different things. If you want to look at the characteristics of long-term memory, how does information get encoded to this deepest layer of memory. Elaborative rehearsal is one way. So you're connecting uh, new information with old information, right? So I'm learning language right now. And if you're learning French, you know the word for house is maison. And how can you remember that? That's it's a new word in a new language. If you know the word in English, mason is a home builder, right? Or I, for some reason, was thinking mansion when I first learned the word. But I'm tying new information to it, information I already have, and it makes it easier to maintain. It's called elaborative rehearsal. We also, there's memories that get made automatically. A lot of times these are emotional memories. Like there might be memories that you have that you don't want to remember. Typically things that are tied to emotional events or traumatic events, or even happy things like things that you remember. You don't have to sit and think about your favorite birthday party like, oh, I want to remember that forever. It's just kind of in there. Automatic encoding. And we'll talk about other ways information gets encoded into long-term memory as well in class. How much information does the LTM hold? We think it's unlimited. I've been seeing kind of some criticisms of that statement recently, but just for our sake in this class, we're going to say it's unlimited. Even if you're 110 years old, there's still space to learn something new, right? I think that's kind of the basic idea behind that thought. All right, how long does information stay in the long-term memory? It kind of depends. And then that's not a great answer if you're trying to learn about long-term memory, but that's really the right answer. There is something called memory decay. It's been shown with the Ebbinghaus forgetting curve, which we'll see in class 2. We'll demonstrate that. You probably know if you think back to one of your classes from 9th grade, you might have gotten an A on the exam demonstrating you knew and had memorized a lot of the material. But if you retook that exam today, 4 years later or 3 years later, you probably wouldn't perform quite as well. So what's happened to information? It's called memory decay, right? But for the most part, the thought is that the memories are still available in the long-term memory, but the problem might come when we try to retrieve those memories. There might be some stumbling blocks in terms of actually retrieving and being able to use that information. We'll talk about retrieval issues as well. Okay, so here we go back to our handy-dandy chart. We'll see a lot of what we just talked about. Anything that we didn't specifically talk about in this video, we will cover in the next video, and we will certainly talk about in class, and it's also going to be covered in the video assignments and the information's in your notes with links into the PDF textbook as well. Okay, so hopefully that kind of helped you understand the 3-box theory for human memory, also called the Atkinson-Shiffrin model for human memory, where we're talking about encoding through the 3 layers: sensory memory, working memory, and long-term memory, and a little bit of information about each layer. Okay.